So this is in regards to what we call one-step mole calculations. We're either going to be going from moles to grams or grams to moles. The main thing is you need to have your periodic table accessible. So this looks very much like we just got through working with the star track, in that we're still doing our dimensional analysis with the railroad tracks. So the first prompt says, how many moles is 35.4 grams of lithium? So just like we did before, we're going to start with what's given, which is the 35.4 grams of lithium. We're going to put that over 1. Now, I go to my periodic table, and I find out that 6.94 grams of lithium is the AMU. And the other way to think about that is 6.94 grams equals 1 mole for lithium. Since grams is on top, I'm going to put on the bottom, I'm going to put 6.94 grams lithium, 1 mole lithium. And now I'm going to simply do 35.4 times 1, which is 35.4, divided by 6.94. So just like in Star Trek, we do the product of the top divided by the product of the bottom. I'm going to pay attention to also my decimal. I have 1 decimal, so it's going to end up calculating out to be 5.1 mole of lithium. Let's try this again with another example. So how many moles are there in 4.56 gram sample of copper? Again, I start with what I'm given, and so I'm going to write 4.56 grams Cu over 1. That 1 is simply a placeholder. I go to my periodic table, and my AMU of copper is 63.55 grams on top. I'm going to place it on bottom, 63.55 grams Cu to 1 mole of Cu. And when I do the math, I get 0.0718, or a better way of writing that is 7.18 times 10 to negative 2 mole Cu. So that's going from moles to grams. What happens if I'm given the number of moles and I want to find out how many grams I have? Well, it's still the same thing. So here's our prompt. How many grams are in 3.56 mole sample of beryllium? Just as we saw before, we start with what's given. We're given 3.56 moles of beryllium, and we place that over 1. I go to the periodic table, and I discover that my AMU of beryllium is 9.01 to 1 mole of beryllium. Moles is on top, so I'm going to put moles on bottom. I'm going to put 1 mole of Be. And now I'm going to put 9.01 grams Be on top. Now I do the operation, the product at the top divided by the product at the bottom. And when I do this, I end up with 32.07 grams beryllium. Let's do another practice problem. How many grams does 15.9 moles of sulfur represent? Same thing as before. I'm going to start with what's given. 15.9 moles sulfur over 1. That doesn't change. I go again to the periodic table and I find out that sulfur is 32 grams per 1 mole. Because again, I go back to the AMU. Moles is on top. It's going to go on bottom. So I'm going to put 1 mole of S. 1 mole of S from the periodic table is 32 grams of S. And when I do the operation, I'm going to get 508.8 grams sulfur. So we've been doing just simply elements with this, but can I also do this maybe with a compound? Absolutely. So I just chose two quick compounds for us to do this in. I have one going from grams to moles and the other one going from moles to grams, just to show you it's the same operation. So the one thing I have to know is I have to know my formula mass or my molar mass. And here I have water. The formula for water is H2O. If you recall right, we're going to add up the parts. So I have 2 times 1.01, which is the AMU, plus 16.00. And so I'm going to get 18.02 grams per mole for the molar mass. I have to have that because that's just like going to the periodic table and getting your information. So here, let's roll forward with this. Same process as before. I'm going to put the 100 grams H2O in the starting position with a 1 over it. Grams is on top. I'm going to put grams on bottom. So I'm going to put that 18.02 grams on bottom for water and 1 mole of H2O on top. I'm going to perform my operation. And after I perform my operation of the product at the top divided by the product at the bottom, I'm going to get 5.55 mole of H2O. And if we're following our only as precise or least precise, I do not have a decimal on that number. And so I'm going to have to round this that I have 6 moles H2O. Let's do one more example where we go the opposite way. So I'm given 1.5 moles of copper 2 sulfate. How many grams is that? Again, I've got to know what my formula mass is because this is ionic substance. So I have, this is written as CuSO4. Copper is 63.55. Sulfur, I'm going to have one of those, and that's 32.00. And then I have 4 times 16.00. And I'm going to add those together. And I'm going to get 159.55 grams per mole. So again, I start with what I'm given, which is the 1.5 moles CuSO4 over 1. 1 mole goes on bottom, and I write 159.55 grams CuSO4 on top. I'm going to perform the operation. And I'm going to get 239.30 grams CuSO4. And since I'm paying attention to the fact I only have one decimal there, I'm actually going to formally record 239.3 grams CuSO4. And that is how you do your one step, whether it's going from moles to grams or grams to moles, whether you have an element or a compound.